Hello, dear friends. Continuing with the instructional videos on the LS-H100 inverter brand. Today, we want to learn together about the digital outputs of the H100 inverter. The H100 inverter has two types of digital outputs, one relay output and one transistor output, as you can see in the diagram. You can see this in the control terminals diagram of the H100 inverter. The H100 inverter has one transistor output, which is the Q1 and EG terminals, and it has 5 relay outputs. So there is one transistor output and 5 relay outputs. In relay 1, you can have both a normally open and a normally closed contact. The B1 and C1 contacts are normally closed, and the A1 and C1 contacts are normally open. The rest of the relays are normally open by default. That is A2 and C2, a 3 and C3, a 4 and C4, and relay A5 and C5. So in the H100 inverter, we have one transistor output and 5 relay outputs from A1 to A5. But to configure the relays of the H100 inverter and the transistor output of the H100 inverter, which parameter should you refer to? The outgroups related to the outputs of the H100 inverter, you need to check parameters 31 to 36. Out 31 corresponds to relay 1 of the H100 inverter. Out 32 is for relay 2, out 33 is for relay 3, and 34 is for relay 4, out 35 is for relay 5, and out 36 is for the transistor output, or the same Q1 terminal of the H100 inverter. So, to configure the relay outputs of the H100 inverter and the transistor output, you need to set parameters out 31 to 36. But according to the manual provided for this inverter 100, if you set any of these parameters we've mentioned here, out 31, 32, 33, 34, 35, or 36, to match one of the numbers you see here, or set it to one of the options listed here, that relay or transistor output will be activated based on the definition you've set. For example, if you set one of your relay outputs, say out 32, which corresponds to relay output 2 to the number 5 or the overload option, as soon as your inverter gives an overload error, your relay output 2 will be activated. Or, for example, if you set relay output 5, which corresponds to parameter out 35 to number 14. Option 14 refers to run, meaning as soon as the inverter starts running, relay number 5 will be activated. So you need to assign a function to each of your relay outputs or transistor outputs. This relay output is supposed to be activated only in the situations you have set. It could be run, it could be stop, it could be steady, it could be a specific fault, or it could be at a certain frequency. So it operates according to the option you have set. Alright, in this tutorial video, we're going to work through an example together. We're going to set out 31 to the value 14, out 31. As we said, this relates to relay output 1, and if we set it to 14, that means we're setting it to the run option. Relay output 1 will be activated as soon as the inverter starts running. Out 32, which is related to relay output 2 of the inverter, is going to be set to the stop option, or value 15, so that as soon as the inverter stops, our relay output 2 will be activated. And out 33, which is relay output 3 of the inverter, is set to value 16. We are going to set it to the steady state mode. Steady state means that you have given a frequency command to the inverter. For example, 30 Hz. The inverter has started up, ramped up from 0 to 30 Hz and is now running at 30 Hz. It continues to operate, meaning it is working at 30 Hz. This mode is called steady state. So the relay output that we have, when the relay output 2 is activated, it's after the stop, and relay output 3 is for the steady or continuous operation mode. Now, what does our wiring look like? If you want to use your transistor outputs, your transistor output is 24 volts DC. For example, If you have a signal lamp, you need to connect one terminal of your signal lamp to 24 volts. The other end of your signal lamp connects to the Q1 terminal and the common of your transistor output. Your EG terminal also connects to ground or the same CM terminal, but if you have a relay output, you can supply either 24 volts DC or 220 volts AC. One end of the signal lamp is connected to either 220 volts AC or 24 volts DC. So whatever supply voltage your signal lamp requires, you connect the other end of the signal lamp to terminal A1, A2, A3, A4, or A5, any of them. You can use any of the relays you want and connect the common terminal C1 to C. This is how it's done. Now let's implement the settings we've learned so far on the device. Then let's do the example we discussed here together. We said that in order to configure the relays of the inverter H100, we need to enter the OUT group related to the relay outputs of the inverter H100. To enter the OUT group, we press the mode key to enter the parameter group, then use the right key to go to the OUT group. Okay, now that we've entered the OUT group, as we said, OUT31 is related to relay 1, OUT32 to relay 2, OUT33 to relay 3, OUT34 to relay 4, OUT35 to relay 5, and OUT36 is related to Q1, which is the transistor output of the inverter. Alright, so as we said, for example, we want relay 1 of our inverter, that is A1C1, to be activated as soon as the inverter runs. We want relay 2 to be activated as soon as the inverter stops, and relay 3 to operate in steady state, meaning when it reaches the command frequency. We want relay 3 to operate, so we go to OUT31 and set OUT31 to value 14, which is run. You see, it's set to value 14. You see that value 14 corresponds to the run mode. We set it to that. As we said, we want relay 2 to activate when it stops. We go into OUT32 and we set OUT32 to value 15, which is the stop mode. Well, you can see that now my relay 2 is activated. Why? Because my inverter is in stop mode and I want relay 3. When it reaches the command frequency, I want it to operate in steady mode. We look at OUT33 and set it to value 16, which is the steady mode. Alright, now if I start my inverter, since relay 1, in run mode, my relay 1 should be activated. So if I start this inverter, as you can see, as soon as the inverter starts, the A1C1 contact closes and relay 1 is activated. And as soon as it reaches the frequency of 40 Hz, my relay number 3, that is to say, how does ACC get activated? So now, if I stop the inverter and it reaches the stop state, my relay 2 should be activated. I'm stopping the inverter now. As soon as the frequency drops all the way down to 0, you'll see that my relay 2 is now being activated. No? I'll start the inverter again. The start mode has been activated. Relay 1 must be activated, and when it reaches 40 Hz, the command frequency. Relay 3 must be activated, then I start the inverter. Relay 1 has been activated. It reached the command frequency of 40 Hz, and my relay 3 was activated, so we learned which group the parameters related to the output relay of the ACH100 inverter belong to, and that we need to set them. How do we set it up?